Okay, so I talk about in control process and out of control process, and we also talk about the control chart and how to see from the control chart that a process is in control or out of control. So this is my UCL. Okay, this is my UCL upper control limit, and this is my LCL lower control limit. So if my data point, my sample points, my measurement points, they are all the time between these two limits, my process is in control. If I have even one data, now I have more than one data that is out of this control limit, upper UCL and LCL, this is a out of control process. Okay, so in control and out of control process, they have, there are more ways to detect if the process is in control or out of control by looking at control chart. We will talk about that today. So not only in case that we have few points or even 1 point out of this control range, there are other cases that although the points are inside the control limit, but the process is out of control, that we will talk about it. Okay, so in control process is a stable, predictable process. Okay, that all the sample points they fall between the UCL and LCL. All the sample points are between UCL and LCL, and although there is some variation, okay, there is some kind of random variation, but all the time the measure points, data points, they are between UCL and LCL, and this variation is due to common cause variation. We already talked about common cause or assignable cause, or assignable causes are also called special causes. This is in unit 1 that you already have it. Please study that unit. Part 1 of this unit. Please study that part, and as I said, if you have any question, I will be always available and happy to answer your questions. So out of control process is an unpredictable process. We don't know what will happen after. Okay, like let's see. Here I can always say that my limits are between these two. My data point will be always between these two limits. But here I cannot say what will happen after this point. If it goes down, goes up, it's unpredictable. And there are some sample measurements, there are some points that will fall out of this upper and lower limit, and this is mainly due to a special cause variation or assignable variation. Okay, now after this slide, I'm gonna give you few figures, and I will ask you to tell me if the process, by looking in the chart, if the process is in control or out of control. There are some rules that if we know those rules, we can, by looking in the chart, we can say the process is in control or out of control. In general, a process can be said that is in control. Okay, by looking at control charts, we can say that the process in control if it has, in general, it has this specification from 1 to 5. Okay, 1 to 5. So, is a random, is a random distribution, is a random behavior. Okay, it just goes up, goes down, goes up. It's a random distribution of the points. There is a sequence of the points that we cannot predict. We really cannot predict the behavior. We don't know what if we have one data point, we don't know really what will be the next data point. It will be lower, upper, increase, decrease. So it's really random behavior. The majority of the points, majority of the points that based on statistics is about 68% of the point, they will be within one standard deviation of the center line. So if this is your control chart, this is your center line, this is your UCL, this is your LCL. So this is center line, UCL, LCL. So almost 68% of the points, data points, they will be in one standard deviation. Okay, one standard deviation from top and one standard deviation to the bottom. Almost 68% of the points, they will be in that range. About 28% of the data points, okay, there will be between 1 to 2 standard deviation. It means a little bit upper here, little bit upper here, between 1 to 2 standard deviation. And that, let's say, they have to be equally distributed to the upper side and lower side. It means when 28, it means 40% of the points that are below the center line, 14% of the points are above the center line. And about 2% should be near the control limit line, UCL and LCL. And none of the points should be beyond the control limit. We shouldn't have any point here or here. Okay, this is a general, typical controller chart that is for a process in control process. Okay, so when we have such a maybe we won't have absolutely all this condition in the control chart, but the typical and majority of the in control process, they have such a properties, such a specification. But those numbers are not exactly the same for all of them, but are very close. In majority case, those numbers are very close. Okay, so most of the time about 68, 65, they are within one standard deviation. About 20 to 28 to 30, even 35, they are within 1 to 2 standard deviation, and like 2% or a little bit upper or lower, they are close to the control limits. So, like, this is one example of in control process. One example of in control process, that this is my UCL, this is my LCL, this is my center line, the target value or average. So, like you can see, almost few data, maybe 2 data points that are close to the center line, to the limits. Majority of the data that are here, they are located, are close to this center line, within one standard deviation, and maybe few data that are located in 1 or 2 standard deviation. Like here, we have 3-4 data here. We have like 4-5 data here. My lines are not accurate, but as you can see, the majority of data that are really close to the center line. Okay, so this is what I explained in the previous example. This is shown here. UWL is upper warning limit and LW is lower warning limit. As I said, it's not important. It's just for you as extra information.